Hello students, welcome to the lecture of Basic Concepts of Chemistry. In the last lecture, we had discussed about the percentage composition and we had solved some numerical problems. Today we will discuss some few more numerical problems of percentage composition. Then we will move forward with empirical formula and molecular formula. So let's start. So there is one question of percentage composition. So the question is, calculate the percentage composition of the following molecules. Okay. So these are the molecules: sodium carbonate, ferric oxide, hydrazine, and aniline. Okay, so let's start. So the first one is Na2CO3 or sodium carbonate. So first of all, we will have to find out the molar mass or molecular weight of this compound. Okay, so we will find out molecular mass or molar mass. Okay, so the molecular mass is equal to mass of sodium into 2, right? So mass of sodium is 23 into 2 plus mass of carbon plus into 1, so 12 into 1 plus mass of oxygen into 3, so 16 into 3. So 46 plus 12 plus 48, which comes as 106 gram. 106 gram if we are talking about molar mass, and 106 AMU if we are talking about the molecular mass. Okay, so this is the molar mass of sodium carbonate. Now we will find out the percentage composition. So percentage of sodium. So what will be the percentage of sodium? So this is atomic mass of sodium or molar mass of sodium into number of sodium divided by molar mass of sodium carbonate into 100, right? So 23 into 2 divided by 106 into 100. So we get 43.40%. Then percentage of carbon. So percentage of carbon is again atomic mass of carbon into number of carbon divided by molar mass of sodium carbonate into 100. So this will be 12 into 1 divided by 106 into 100. This comes as 11.32%. Then percentage of oxygen, similar, atomic mass of oxygen into number of oxygen divided by molar mass of sodium carbonate into 100. So, 16 into 3 divided by 106 into 100, which comes as 45.28%. Okay. So, this is the percentage composition of sodium carbonate. The second molecule was ferric oxide, Fe2O3. First, we will find out the molar mass or molecular mass of ferric oxide. So, mass of iron into 2. So, mass of iron is 56 into 2 plus mass of oxygen into 3. So, 16 into 3. This comes as this is equal to 160. Okay. So, now percentage of iron. Percentage of iron is 2 into, that is number of iron into mass of iron divided by molecular weight of ferric oxide into 100. This comes as 70%. Okay. Now, percentage of oxygen. Percentage of oxygen is again number of oxygen into mass of oxygen divided by molecular mass of ferric oxide into 100. So, this comes as 30%. Okay. Now, the third molecule. The third molecule is NH2NH2, or we can say this is hydrazine. Okay. So, NH2NH2 can be written as N2H4, right? So, we will find out the molecular mass. So, the molecular mass is mass of nitrogen into number of nitrogen. So, 14 into 2 plus mass of hydrogen into number of hydrogen. So, 1 into 4. So, this is 28 plus 4, that is 32. Okay. So, percentage of nitrogen is mass of nitrogen into number of nitrogen divided by molecular mass of hydrazine into 100. This is 87.5%, and percentage of hydrogen is equal to mass of hydrogen into number of hydrogen divided by molecular mass of hydrazine into 100. So, this comes as 12.5%. Okay. Our last example on percentage composition is aniline. So, what is aniline? The structure of aniline is this. Okay. Benzene ring with one amine group, that is NH2 group. So, the formula of this is how many carbons are there? 1, 2, 3, 4, 5, 6. So, 6 carbons are there, C6. Now, in benzene ring, there is one hydrogen with each carbon. Okay, and these are carbon. Okay. So, there are 5 hydrogen. So 5 hydrogen plus NH2 has 2 hydrogen. So 8, 7, and we have 1 nitrogen. So C6H7N. This is the molecular formula of hydrogen. It is generally written as C6H5NH2. Okay. So we will find out the molecular mass of aniline. So mass of carbon is 12 into 6 carbon are there. Mass of hydrogen is 1 into 7 hydrogen are there, plus 14 into 1. So this comes as 93. So percentage of carbon is equal to mass of carbon into number of carbon by molecular mass of aniline into 100. So this comes as 77.42%. Then percentage of hydrogen. This is equal to mass of hydrogen into number of hydrogen by 93 into 100. This comes as 7.52%. Okay. Then the percentage of nitrogen. So mass of nitrogen into number of nitrogen by molecular mass of aniline into 100. This comes as 15.05%. So now we have completed the unit of percentage composition. So the next topic is empirical formula and molecular formula. So what is empirical formula? Empirical formula is the simplest whole number ratio in which we can represent the elements of a molecule. And the molecular formula is the actual ratio or actual number of atoms of each element that is present in a molecule. Okay. So empirical formula is a simpler version of the molecular formula, and we can easily derive the molecular formula from the empirical formula if we know the total molar mass of the compound. Okay. So now we will discuss about empirical formula, molecular formula and their calculations. We will start with empirical formula and molecular formula. Okay. So first we have to define these two. So empirical formula represents the simplest whole number ratio of the atoms of each element present in the molecule of the substance. Okay. Empirical formula represents the simplest whole number ratio of the atoms of each element present in the molecule of the substance. And molecular formula of a compound expresses the actual number of atoms of each element present in a molecule. Okay. So, empirical formula represents the simplest whole number ratio of the atoms of each element present in the molecule of the substance, and molecular formula of a compound expresses the actual number of atoms of each element present in a molecule. So, molecular formula is equal to empirical formula into N. Okay. So, this is the formula for converting molecular formula and empirical formula. So, this N factor, this N is any positive integer. Okay. N is any positive integer. So, this N is calculated when we know the molar mass of the compound. So, let us have some examples. So, carbon dioxide and water. Okay. Both of these molecules, this is the molecular formula of them, but they cannot be reduced in any more simpler form. Okay, this is the simplest form. So, carbon dioxide and water have both empirical and molecular formula same. Okay. But there are certain molecules, for example, let us say ethane. Okay. Ethane is C2H6. But if we divide these coefficients by 2, then it becomes CH3. So, C2H6 is the molecular formula of ethane and CH3 is its empirical formula. Okay. Similarly, we can list some more examples. Okay. N2O4, this is the molecular formula. Its empirical formula is NO2. If we multiply by 2, then NO2 becomes N2O4. So, this factor is N. Okay. So, here N is equal to 2. Here also N is equal to 2. Again, if we take C10H22, the empirical formula will be C5H11. Here also N is equal to 2. Now, we have benzene C6H6. The empirical formula will be CH. So, here N is equal to 6. So, these are certain examples that we have learnt about empirical formula and molecular formula. We will study about the detailed calculations in the next lecture. Thank you.